Hi, my name is John Brunhaver. This is a project I built with Samantha Brunhaver as a part of Stanford's Beyond Bits and Atoms class. The goal was to build a bifocal model. A bifocal model is when you take a real physical system, so in this case an RC circuit, capture what's going on in that real system with sensors, so in this case using the ADC on the analog to digital converters on the microcontroller, taking the sensor data, driving that into the computer, and then comparing it to a simulated system. So in this case, we're simulating the circuit that we had breadboarded over there and comparing the two waveforms. So we built a system to explore RC circuits. We chose RC circuits sort of because they're interesting and easy to evaluate in transient. In general, we were hoping to build a system that could compare any circuit a student breadboarded to a circuit that was simulated in real time. That was sort of difficult. In this case, what we did was we set up 3 RC circuits for students to look at. So in this, we have a triple RC, a single RC, a double RC. So the other thing we did was we chose large time constants for these RCs. So this RC pair, its time constant is about 2 seconds, meaning that it can take a while for the system to rise to a specific level. Why don't we take a look what's going on? So we have our simulated system and our real circuit. So we'll turn on the voltage source. We'll drive it from 0 to 5 volts. We'll turn it up from 0 to 5 volts. And we can see the rise in the simulated circuit. So at the same time, what we can do is we can turn on the motor, so increase the voltage, drop. The motor is driving across the circuit, so the voltage source and the motor are sort of similar. We can see that they're sort of rising together. There's a few things to note about what's going on. So the black line represents the voltage source or the motor. The first line to rise is the blue line, which represents the first capacitor. The second line to rise is the green line, which represents the second capacitor, and the red line represents the third capacitor. The reason they go in this order is that as the voltage source dumps charge onto the first cap, its voltage increases. And as enough charge is accumulated on the first cap, it begins to both shift current from the voltage source onto the second cap and begin sharing some of its charge. The reason that there's a delay in this happening is that the resistor there limits the amount of current that can be shifted through without a high voltage on the first cap. There are some differences between the two models. As you can see, there are a few sort of hiccups in building a system like this. So one problem is that in NetLogo, there's not really a great way to tie the ticks to a time constant. So this was simulated as though the ticks were always 0.02 seconds, but that's not always the case. The other thing that's happening here is we have a lot of trouble controlling the voltage that the motor drives. So sometimes it's at 6 volts, sometimes it's at 8 volts. So in this case it's kind of high, and so it was driven fast really quick. The other thing is that this was sort of hand-tuned. Well, it wasn't very well hand-tuned. What we did was we just matched the RC values in the simulation to the RC values in the circuit, and then we sort of estimated the time of a tick and then used that as the time constant. A more elegant system might have solved those problems and built general solvers. So we backed the system with discrete differential equations, which also introduced some amount of error. Thanks for listening. Have a good day.